let's take a look at what happens when you're given an angle measurement and you also know the lengths of two sides. If the angle is acute, you have to consider, we'll call it angle A. You have to consider side A, which would be opposite to angle A. If that side happens to be less than the other side in length, we also have to consider this imaginary height of the triangle. So this would essentially be a hypotenuse that would be created with side B and a separate side um, other than A up into that point. So this height here that you can see, H, if that is also larger than A, then there is no solution. You don't have a long enough side A to complete the triangle. Now, if this side A is less than B and A is equal to H, that means that A is the same line as that H that we defined, then you have a right triangle here, and you have one solution for that. Where you might have more than one solution is if A is less than side B here, but it's greater than this height H, because A could be swung inward or it could be swung outward from H. And you have two possible triangles. If A happens to be greater than or equal to B, this other side here, then you have one solution for your triangle. Now, looking down here, if the angle A happens to be right or obtuse, if um, A is less than or equal to B, you don't have enough length there to create a full triangle, so there are no solutions. On the other hand, if lowercase a, the side, is greater than side B, you do have one triangle possible. So let's take a look at a couple examples to solve. So in this case, our angle is 63. The side opposite to that angle is 18. And then our side adjacent to that angle is 25. So if we look at this, we have an acute angle. So we're looking at the top row. And we have A is less than B. So we're looking at one of these three possibilities. So what we're going to do is we're going to have to find H. And since the sine of angle A would be the opposite, which is H over the adjacent, which is B, then H, when we solve that for H, is going to be B sine of A. So let's solve for H, which would be B sine of A, or 25 sine of 63. When I put that into my calculator, I have 25, and let me make sure I'm in, no, I need to be in degrees. So I have 25 sine of 63, should be 22.3. Notice now I have two conditions here. A, again, is less than B. A is also now less than H. When A is less than B and A is less than H, we have this scenario here, so there is no solution for this triangle. So let's take a look at this example in which we have an A that is greater than B. So now we're looking at one of the bottom two situations. Or actually, before I meant to say that our angle is obtuse, which is why we're looking at the bottom situations, but A is also greater than B. So we have an obtuse angle, meaning we're looking at the bottom two, and A is greater than B, so we do in fact have one solution. So let's go ahead and solve that triangle. So we know we have some angle here that's 105 degrees. and then some side that's 55, and then the side opposite that 105 angle is 73. So we can't do anything to find this other side because it's not a right triangle, but we can use the law of sines. And I should say we can't do anything yet, but for now, what we have is the law of sines. We can use that to find this particular angle here, which would be angle B. So we have the sine of 105 over the side of 73. We have the sine of this mystery angle, B, over side B, which is 55. When we cross multiply, we get 55 sine of 105 equals 73 sine B. So sine of B, when we divide both sides by 73, is going to be 55 sine of 105 over 73. So in other words, if I take the inverse sine of both sides, B would be by itself, and B is now going to be equal to the inverse sine of this expression here, 55 sine of 105 over 73. So let's put that all into the calculator. So we have B is equal to the inverse sine of 55 sine of 105 divided by 73. Make sure all your parentheses are closed. Sorry, I actually had to retype that because I forgot the extra 5. It's 55 sine of 105. So my B angle ends up being 46.7 degrees. So that's what this angle is here. That would allow me to find the third angle, which we can call C. And 180 minus 105 plus 46.7. It's going to give us plus 46.7, and that's going to give us 28.3. And now we have enough. We've always had enough to solve for that third side, but we do have that angle as well. So the third side, which would be little c, we can use anything. We can use sine of, why don't we just keep with 105 over 73 equals sine of 28.3 over side C, cross multiply, C times sine of 105 equals 73 sine of 28.3. And then so C will be 73 sine of 28.3 over sine of 105. When I put that in my calculator, I get so 73 sine of 28.3 divided by sine of 105. I get 35.8 for my lengths of C, and those are all my missing pieces to completely solve that triangle. So do your best and see if you can find whether there is a solution for triangle ABC and what those values would be.